Hey guys, welcome to today's video. Today we're going to be looking at Bcrypt, and especially in the context of PHP and Node.js, and going to take a little bit of a look on the history, the description of it on Wiki, and the reason I'm doing this is because we recently at the company I work for had a requirement to migrate users to a new external identity provider. And in order for our existing users to not have as much friction, we have to migrate the password hashes as well. So the issue with that is that, and the reason we're doing it is so that when users use the new login interface, they wouldn't need to reset their passwords or create new passwords. And this can cause a little bit of friction, and you might lose some users if they just reject the idea of needing to create the new password. So we really want to make it frictionless, and the system we're sort of moving from is PHP Laravel, and it uses the PHP built-in password hash functionality to hash the passwords. And the new system will probably be based on Node, or well, this could be used in any other sort of system, but what we're going to be looking at is the Node.js migration. Hey guys, before we get started with the video, I just want to tell you about an awesome deal that we have on Superdance. A disclaimer is that I am a developer, the lead developer of Superdance, but this is a very cool deal, and Superdance is a sponsor of this channel. So you can check out the lifetime deal on Superdance that we launched, which saves you like 96% on your entire purchase over 4 years. So what this does is you buy coupons on the Superdance website. You can click on the link in the description or go to this page, and you will see that there's an LTD. You can follow that link, and if you buy one coupon, you'll get a solo plan for life. If you buy 2 coupons, you'll get a team plan for life. And if you buy 3 coupons, you'll get a company plan for life, which allows you to point your own domain to Superdance. It allows you to update your branding. It also allows you to invite 25 members to your team, and they all get their own custom Superdance page, which is quite awesome. And above that, I have a special offering for you guys. You can use my discount code on the screen. And if you use that discount code when buying your coupons, you can actually get a further 35% off. Please make sure when you check out on the LTD page, do not buy more than 3 coupons. The payment provider does allow you to select more than 3, but our system at the moment just allows 3 coupons to be redeemed, or you can redeem more, but it's not going to give you any more benefits. So just please make sure to check maximum 3 quantity in on your basket. You'll receive an email with your coupons. You create your Superdance account, you go to the subscription settings, and then at the bottom of the screen you'll see that there's input to enter your coupon codes one by one, and then as you redeem them, the page will refresh and your account would be upgraded. And if you just feel like trying out Superdance, remember there's a 100-day free trial. So these are pretty cool deals, and I really encourage you to check them out. Let's get to the video. To get started, let's have a little bit of a look at what the password hash looks like and what it means. So the specific system that we are using uses the Bcrypt algorithm, the blowfish algorithm, and this is what the hashes look like typically. So the structure of the hash is a $, and then 2y, $, a number, $, these characters, and the first 22 characters here are the salt, and the characters following that is the actual password hash, and you can read more about that on this wiki. So what I'm going to do is I'm going to copy this link, and I'm going to put it on my public Superdance page so that you guys can follow along. So I'm going to create a new category called let's do a lock, and we'll say Bcrypt video, not that, Bcrypt video, new keyboard. Alright, so we'll create that category, and then I'll add the PHP site where you can generate Bcrypt passwords. So let me just do it this way. I'll add this npm package to superdense, and I'll also add the wiki to superdense on the description tag. So we'll paste that and then add it. So if you guys want to follow these links, you can go to this URL, bookmarks.kaizen.com.na, and just look for the Bcrypt video category. That should have all the links available that you need. So anyway, let's look at what this does. So let's say the user created an account on the PHP platform with the value of password, a very secure password, obviously. And this is the hash that it generates. So the point of this is to sort of use Bcrypt, and when the user logs into the new interface or the new system, we have to take the plain text password that they entered and we have to hash it using the Bcrypt algorithm and compare it to this. And Bcrypt has a nice way of doing this. You can actually just call compare sync with the plain text password and the hash, and it should return true or false. So we don't need to rehash the password and compare the hashes, but we can if we want to. So to get started, I'm gonna create a new directory called Bcrypt explore. I'm gonna cd into Bcrypt explore. And I'm just going to do a yarn init-y, and we can do yarn add bcrypt. While that installs, we can look at the wiki. So like I said, the structure of the hash looks like this. The first $sign plus the value inside, 2a or 2x or 2b or 2y, tells you the algorithm. The number after the second $sign gives you the amount of salt rounds that was used, and the 22 characters following the third $sign gives you the salt that it generated, because with Bcrypt you use the module to generate a random salt. You don't actually give it a salt. And then the last few characters are the actual hash of the password. And if you want to try and implement Bcrypt, you can actually follow this code and create your own Bcrypt algorithm, but let's not try that today. And let's have a little bit of a look at the algos. So because this is important for what we're going to do in Node in a moment. So the original specification did not define, let me just hide my iRes tool. So it did not define how to handle non-ASCII characters. The specification was revised to specify that when hashing strings, blah, 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 all that. Then the version became this, 2a. And 2x and 2y are sort of ways for the user of the hashes to know if what this hash represents. So the 2x became used to indicate that those hashes are bad, because at a certain stage a PHP implementation of Bcrypt was mishandling characters with the 8-bit set. So for sort of a convention, they had to generate these 2x algos to indicate that this was used with that faulty code. And they also suggested the idea of emitting 2y for hashes generated by the fixed algorithm. So you can see that in the PHP implementation, they now use 2y because they want to indicate that this is a fixed algorithm. It's no longer the faulty 2x. And if you we'll look at Node.js in a bit, you'll see that Node.js outputs the 2b because there was a bug discovered in OpenBSD. They were storing the length of their strings, blah, blah, blah. So there was an overflow if the password was longer than 255 characters. So it would overflow and wrap at 255. So the bug caused them to bump the version to 2b, and that's what Bcrypt in Node uses. So you can see that even though the algorithm is the same, the hash outputs could be different from different platforms. And this is where it could be difficult to understand how to compare passwords to make sure that even though this was generated on PHP, you can still compare it in Node and make it work. And that's what I want to sort of go through today. So the packages I have installed, what I'm going to do is open code with this folder. And I think I installed the latest version of Bcrypt, which requires me to say that this is of type module. And I just got to make sure that my Node version is, yeah, that will be good. And I hope that's good. And then we need to create a new file called index.mjs. And what we can do maybe is just add a script to make this a little bit easier. And we can say start. And we'll just say that node index.mjs. Let's make sure that this works by doing console.log iWorks. And let's try start. And looks like it works. So to get started, what we want to do is we want to require the Bcrypt. Let's first generate some, or let's use the PHP one that we generated. So we know plain text is password and this is the hash that it generated. So what we want to do is we're simulating that this is the hash stored in the database and a user is going to come in, log in on our new system. So we need to be able to compare this password with an old version that was stored in the database. So let me just zoom in so we can see a little bit more. Then I'm going to do, I think I can do import if it's MJS, I'm not sure. So let's try that, Bcrypt from Bcrypt. And what we want to do, let's just store this value over here. Let's do legacy password equals a object, an object with the plain text being password and the hash being this. So obviously the system won't store this password. We're just keeping it there to know what the actual password is. We actually can just leave it off and hard code it in there. Let's just do this. Let's say that the user supplied password is equal to the password, and we'll leave that out. And yeah, let's just do that. Okay, so what we want to do now is compare the actual plaintext password to the PHP hashed version, and it seems like it should be simple enough. So let's say const matches equals bcrypt dot compare sync, and then we'll pass it the password, which is the user supplied password, and we'll also give it the legacy password dot hash. So basically what we're asking Bcrypt to do is take this password, hash it, and then compare it to this hash, because hashing is a one-way thing. You can't decrypt a hash backwards again, so it needs to rehash the original and then compare it to the hashed version. So let's just do console.log matches, and what we expect to see is a true, right? Because the user supplied password is password, and we know that this hash was generated with Bcrypt based in PHP. So let's do yarn start, and we don't see anything being logged. And that's probably because I didn't save the file. So let's save and do yarn start again. And you'll see that it returns false, which is odd because it's the same password. It uses Bcrypt as the hashing. It should compare it. But this is where the issue with the versions come in. Sorry, not that, these versions. Node generates the $2b passwords, and I can show you that quickly. Let's do const hashed equals the bcrypt hash sync, and we'll just give it the salt rounds, and we know based on the structure of this that the salt rounds is 10, so we need to replicate that. We can first give it the password, so the user supplied password, and then we give it the salt rounds, which is 10. And then let's comment this out for now, and we'll just log the hash to see that how does Node.js hash this password. So we'll do yarn start again, and you'll see that, let me copy and paste this here. The hash password looks a little bit different in Node. So it starts with 2B, and it also has the 10 salt rounds, but then the salt sort of changes and the hash looks different. And this is the issue. We don't really care about any of the other things because it doesn't make sense, but what we need to care about is the algorithm. Why is Node using 2B and why is PHP using 2Y? And that's because PHP needs to use 2Y to indicate to the users that to indicate that they are using the fixed algo, since the broken one was 2x. And you would think that, okay, well, so all I really need to do is let's clear that out. And so all I really need to do is change this from 2y to 2b so that the algo is the same, right? So we can take the hash and then let's replace the $2y, and let's just add that $ as well, and we'll replace that with $2b so that it matches the Node version. So we'll expect that this sort of works, right? It uses the same algo, so it should do what we expect it to do. So let's try that. Let's see if it matches. We'll do yarn start, and we get true. So we've now changed the algo to from 2y to 2b by replacing 2y to 2b. And I actually thought that this wouldn't work because there's a weird other situation where you can actually replace the 2y with the 2a algorithm. And this didn't make sense to me, but I never tried replacing it with 2b, so now I've also learned something. But you can actually use 2a, which is weird because neither of these passwords indicate that they use the 2a algo. So I'll show you that, and we can do yarn start, and it still matches. So the user is authenticated because they supplied the correct password, which compares sync. And we can do this a little bit more involved as well. So we can write a function that says, so let's write a function. Let's say const hash equals a function that takes a plain text password. And what it's going to do, it's actually going to define a salt. So you wouldn't do this in production, but just to sort of see how this might work, let's do this algo again, paste that, and then we can do the 10 as well. Actually, we can do this whole thing, and it's up to that point is 22 characters. So that will be the salt, and this is if you don't want to supply a salt rounds, you actually want to give it the salt, and you want to use the same salt. So that will be the salt, and then we can say that we can return bcrypt .hashSync and give it the plain text password, and instead of passing in a number, we give it the string that is the salt. And let's do console.log hash the user supplied password, and I expect this to break. Let's see, and you can see that Node says invalid salt. Salt must be in the form of version, log2 of the num rounds, and the salt value. So let's try to replace the version to see if that works. So let's do the Node version, which is 2b, and we can do yarn start again, and there you go. Now you can see that Node has generated this hash based on the original password. And if you take this hash that Node now generated and you compare it to this hash, you'll see that it is exactly the same hash except for the algorithm. So that's just a way that to test it. You'll probably never do this in production. You'll always give it the rounds, and the fact that you know that it's 10 rounds and all your users generated in Laravel use 10 rounds or whatever PHP or whatever platform you used, Bcrypt, you can tell the number of rounds from this so that you know how to implement the algo over here and keep your hashed passwords consistent. Bcrypt should actually know how to compare anything because it itself reads the data from the hash, so you don't really need to worry about that. But just to keep it consistent when adding new users, and you hash their passwords so that you stick to 10 salt rounds instead of changing it to something else and getting inconsistencies in your database. So, and what you can do, another thing that you can do, let's take this hashed password. Well, that will be Bcrypt, Node. So let's use the PHP one, and we can go to this password hash, and I think there is a verify one as well. I've been trying different tools. So the password is password, and the hash is this, and you can verify it, which basically runs like the same functionality as the Node.js Bcrypt. But if you use the Node versioned 2b, so maybe you're transferring users from Node back to PHP, and you try and compare this, it seems like it still works. So PHP does take that into account, which is great. But if you use Node, then you'll need to replace the 2y with a 2b or a 2a. And there's actually a sister library which I haven't explored too much. I think it's called Twin Bcrypt. Yeah, it's over here. So this library, I don't know how maintained it is and how secure it is, but basically all it does is it just makes you not have to worry about doing this step. Let's go back. So you don't have to worry about doing this step. You can actually just pass it the 2y version and it will take care of that for you. But this is a safe implementation because only if the string does have a $2y then it will replace it with 2a or 2b. So normal passwords that don't have that, or the other passwords that don't have that, would still be safe. So yeah, thanks for watching. I think I'll take this tool as well and just copy it and add it to the Bcrypt video category, paste that, let it load, and there's all the information for the video's links, and I'll just move that up to the first column so that in the public page you'll be able to quickly see that. Let's see if that's saved. Alright, so this is the Bcrypt video links. These are all my other public links. You can check them out too if you want. And yeah, thanks for watching. I hope this sort of helped, or well, it was just a fun exploration for me. But until next time, please remember to like, subscribe, leave a comment, and yeah.